All right, number 10. So once again, check for a GCF first. 18, 48, 32. If you already know what it is, that's great. You don't have to go through all this, but this is a good system if you don't know. So 2 times 9 is 18. 9 breaks down to 3 times 3, so it's 2 times 3 times 3. So I can see that both these are even, so I know 2 goes into them, right? So 2 here, 24. And then I want to check for 3's. So 24 is 3 times 8, and 8 doesn't have any, right? So far, 8 doesn't have any 3's. So far, I have a 2 and a 3, right? This 3 is not going to work because, and actually this 8's not going to work either, because no 3 goes into 8, and 8 doesn't go in anything in the 18. And so then 32, does 2 go in? Yes, it does, 16 times. Does 3 go into 16? Nope, does not. So that means that 3 is out of the question. So it's just 2. So I'm going to factor out a 2. No, there's no variables that are in common, right? So then I'm going to divide each of these terms by 2. And so on the inside, I'll get 18 divided by 2 is 9, x squared. 48xy divided by 2 is 24xy. Let me do a better job with the x. And 32y squared divided by 2 is 16y squared. Okay, so now we do have a complex quadratic here, and we can multiply 9 times 16 and do all that. But I'm noticing something familiar about this one. We have a perfect square here, right? 9's a perfect square, x squared is a perfect square, and we have a perfect square here, right? So when that happens, if we take the square roots of them, 3x and 4y, and we multiply them together, we get 12xy. And then if we double it, we get 24xy, right? 2 times 3x times 4x. So if we multiply them together and double them, if we end up with that, that means it's a perfect square trinomial. So instead of going through the process of a complex trinomial, this is a shortcut. We can put the square root here, 3x, square root of 9x squared. The square root of 16y squared can go here. And then whatever sign this is going to come down, right? So it'll be plus. And that's all we have to do. Okay, so that would work if we did it the other way, but this way is probably a little faster. All right, let me show you a couple more things. I'm not going to do these all the way, but sometimes you have binomials, right? So there you factor out the GCF, and then you check if it's a difference of 2 squares. I can already tell since the signs are both positive, it's not going to be a difference of 2 squares. So here I'll just have to factor out the GCF, which happens to be, let's go through this a little bit fast, 4a. And so then I'll get 7a plus 3b, and there's nothing I can do with that, right? So that's as far as we can go, okay? All right, and then sometimes you will have a difference of 2 squares. Here, factor out the GCF, so that would be 3. So I'll get 4x squared minus 9y squared. And then that can be factored as a difference of 2 squares, right? 2x plus 3, 2x minus 3, because those are the square roots. Square root of 4 is 2. Square root of 9 is 3. All right. And then last but not least, I wanted to just show you this is a grouping situation. We're not going to do this one all the way out, but once again, check for a GCF. And then once you find it, bring it all the way to the front. And then the leftovers you're going to factor out with the grouping method.